Okay, let's try this. I'm going to be doing a video on my computer now because that other camera wasn't working as I wanted it to. I'm going to try to do this. Let's see if I can go back and forth. If I can, then I can make this work. Yeah, there it is. So I can go back and forth. Okay, good. Okay, so here I am. We're doing the next round of videos for labs this week. Your labs, these are demonstration videos. You can download a file saying, video information or heart and blood pressure video. I think I'll call it that. Put it on the site for you, and write down this information. Some of this information will show up on your lab practical because this is a lab. What we're doing with this round is something called pulse wave velocity. Now, when your heart beats, when it's in diastole, it's totally relaxed. No blood's going out. When it's in systole, it's pushing the blood out. But the blood takes a little while to reach your extremities. However, the pulse doesn't. It takes a tiny bit of time, but not very much. Be like if you had a long garden hose that was full of water, you turn the water on, and there's a brief time before the water comes shooting out, because these molecules have to push these, have to push these, have to push these, have to push these. And so the pulse, even though it's not this water coming out this end right away, it takes a brief time before that water reaches the end of the hose, or it pushes water out of the end of the hose. That's the same thing with the pulse wave. When your heart beats, it pushes the blood in the direction of your extremities, and that pushes blood, and your pulse shows up in your extremities. Now, if you've taken your pulse before, if you haven't, what you do is you put your fingers on your radial artery. And the best way to find that is to go to this radial styloid process here, stylus, and roll just inside and push down, and you can feel your radial artery beating. Okay? And that's how you take pulse at the wrist. You take the pulse at the carotid artery by putting the fingers on one side, not both, or you can cause the person to pass out. Press just in front of the sternocleidomastoid there, and you can feel the pulse. And now try this while I'm sitting here. See if you can make this happen. While you're feeling that pulse, reach around and grab your radial pulse with the other fingers. And see if you can feel both of them at the same time. If you do, you'll feel that the one at the neck is just before the one at the fingers. Okay? Because your neck is closer to your heart than your fingers are. And so that's the rate of the pulse, making it from here to your extremities. The important thing about that is a good, soft, young blood vessel is so stretchy that it slows down that pulse rate. It can take its time getting there. It's still really fast, okay, but it's a little bit slower making it out there because it's going through this nice soft tube that slows it down. So the pulse wave velocity on a young healthy person, like most of my students, tends to be about between 3 and 4 meters per second. Is the, about like that, is the pulse wave velocity for a young person. For somebody my age, in my late 60s, I have a certain amount of hardening of the arteries that just comes with age. There's nothing you can do about it. Mine is going to be faster than that, because the harder the blood vessel, the less stretch, the faster the blood goes zooming through it, because the stretch doesn't allow that diameter to get slightly larger and slow it down. So the slightly harder arteries will create a higher pulse rate velocity, and mine will probably be somewhere between 5 and 6 meters per second. That's okay for somebody my age. If it makes it up as high as 12 meters per second, that is way too fast. That's diagnostic of coronary disease, or a blood vessel disease, at least arteriosclerosis, because your blood vessel is so hard it's like blowing it through a plastic straw. There's no stretch at all. So 12 meters per second is diagnostic of artery disease. So what I'm going to do, I've already hooked myself up again. I'm hooked up to, this time I'm hooked up to my BioPac system that I bought on eBay, so I'd have one to teach with. And I'm putting a pulse detector on my fingertip. This is a lot like a pulse oximeter, except it's not doing the oxygen part. It's just telling us when the pulse is there. Okay? And now I'm going to see if I can get to my BioPac system. Can I go to there? Okay, so let's get to BioPac. Here we are, BioPac. And we're going to go to EKG2, ECG2. Just choose a generic file name. Yeah, I'll do that. Okay, so here I'm going to have two things showing on here. I'm going to have my ECG, and I'm going to have my pulse. So if I hit calibrate here, so it'll show it. Okay, what's not being detected here? Electrode assembly. Try again. Let's try swapping these. Maybe that'll do it for us. There's the electrode assembly, and there's the pulse one. Try again. Okay, let's try this again. So, did my electrodes come loose? No, they didn't. Try it one more time here. Try getting out of that. Try going back to BSL lessons. ECG2. Use it. Calibrate. Electrode assembly not found on channel 3. Well, but it was working just a minute ago, so it was finding it then. Try again. Aha! Oh. But I'm not seeing the ECG showing up. Display. Aha! This one has fallen off. That could have something to do with it. Redo calibration. Calibrate. Try again. Okay. Heavens. Having equipment issues today. If we can get this to really snap on right. Let's redo the calibration. Let's calibrate one more time. See if it's going to work. calibrate. Okay, I think this is going to work this time. Let's try this. Let's try recording. Okay, this is going to work. Okay, you can see on the top line my pulse wave. Okay, and you can see, if we're going to look a little closer, you'll see that there's a little dichrotic notch after the pulse. You can see on the bottom we have the EKG showing there's a PQRST every time. It looks about the same every time, blah, 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 blah. So what I'm recording here is my heart beating and the pulse wave that is coming slightly after that. Now I'm going to shut up for a second and see if I can get a few really good beats that we can use to analyze. Okay, those look good. All right. Suspend. I'm done. Are you sure? You better believe I'm sure I'm done recording. Okay. Let's analyze the current data file. And I'm going to choose these ones that I got that look pretty good here at the end. Okay, and I'm going to auto scale so we can see them better. Okay, so I have here's my ECG. Here's my ECG, followed by the pulse wave. So this heartbeat is causing this pulse wave to reach my fingertip, and you can see it's a little while later. Okay? Heart beats, and the pulse wave shows up. So let's look at the delta, which means the difference between the two. Here we go. There's delta. So let's look at the difference between the two. Let's look from the end of the ECG, which is when to the initial, when the pulse is first reaching there. So let's try this. Try a different one. Delta, yeah, that's it. Delta time. That's what we're looking for. Delta time. 0.196 seconds. So it's taking 0.196 seconds for the pulse to leave the heart and first reach the fingertip. 0.196 seconds. Okay, well, we can write that down. 0.196, 0.196 seconds. Now, how far did it go in that amount of time? Well, I happen to have a handy dandy measuring tape here, and we're going to measure this in meters because our units are going to be meters per second. If you know how far you went and you know how long it took you to get there, then you know how fast you were going, right? If you went 100 miles and it took you 2 hours, 100 divided by 2 is 50 miles per hour. Miles divided by hours, okay? So here we have the distance that it went from here to my fingertip is right at about, let's see, my finger isn't completely stretched out because I'm holding it. Let's say it went 0.93 meters. 0.93 meters. 93 hundredths of a meter. So it went almost a meter in 0.191 seconds. 0.196 seconds. So 0.93 meters divided by 0.196 seconds is 4.74 meters per second. I said I would be somewhere close to 5. That's faster than you guys would be, because you guys have nice, slow, young blood vessels. Mine are getting old and crotchety, like me. Okay, so what we did was we looked at the time it took to get from when the beat finished till the pulse arrived at the fingertip. We got that time, and we measured the distance it went to reach my fingertip, and then distance divided by time gave us meters per second. And 4.4 3/4 meters per second is a decently healthy blood vessel pulse wave velocity for a guy my age. And my technology is trying to fail me today, but I managed to get through it anyway. Yay. All right.